Hello students, my name is Nitin and this is the first class of 11th class. We have many chapters of 11th class, but today we have start with the complex number. The chapter number 5. Chapter number 5 is complex number. In the complex number, we have a small definition. The definition is if the number is in the form z equal to x plus iota y, then we call z is the complex number, where x is the real number and y is the imaginary number. Y is the coefficient of iota and every coefficient of iota is called imaginary number, where this is the iota. The value of iota is root minus 1. Okay students, so z equal to x plus iota y is the complex number. The complex number is the combination of real and imaginary number, and the sign of imaginary number is iota. So z equal to x plus iota y is the complex number. Let me have an example. The example is 2 minus 3 iota. We find real and imaginary part of complex number. So z equal to 2 minus 3 iota, where 2 is real number and we know that minus 3 is the imaginary number. Let me have another example. Z equal to minus 2 upon 3 minus 3 upon 2 iota. So we know that this is in the form of x plus iota y. So the value of x is minus 2 upon 3 and value of y is minus 3 upon 2. So we know that the complex number is in the form of z equal to x plus iota y, where x is the real number and y is the imaginary number. Okay students? Now the values of iota. Let me start with the values of iota. We know that the value of iota is root minus 1. Now, iota square is the multiple of iota into iota. So we know that the value of iota is root minus 1 and value of iota is root minus 1. So this is the square of root minus 1. So root is cancelled out by square. So we find value is minus 1. Now iota power 3. Iota power 3 is multiple of iota square into iota, and we know that iota square is equal to minus 1 and value of iota is root minus 1. So we find value of iota cube is minus root minus 1. Again, the value of iota raised to 4 is multiple of iota square into iota square. We know that the value of iota square is minus 1 and value of iota square is also minus 1. So we find value of iota power 4 is equal to 1. Now we use this process again. Iota power 5 is equal to iota power 4 into iota, and we know that power of iota power 4 is equal to 1. So this is 1 into iota. So answer is iota. Now iota power 6 is equal to iota power 4 into iota square. We know that power of iota power 4 is equal to 1 and multiple of iota square, and we know that the iota square is equal to minus 1. Again, iota power 7 is iota power 4 into iota power 3. Iota power 4 is equal to 1 and this is iota power 3. So this is iota power 3. Now iota power 8 is iota power 4 into iota power 4. We know that iota power 4 is equal to 1. So 1 into 1 is equal to 1. So value of iota is root minus 1. This is minus 1. This is minus root minus 1 and this is equal to 1. So we know that value of iota is root minus 1. Iota raised to 5 is root minus 1. So this is similar to this. Again, sorry, this is similar to this. Again, iota square is minus 1 and iota raised to 6 is also minus 1. So this is equal to this. Now iota cube is minus root minus 1 and this is also minus root minus 1. So this is also equal to each other. Now iota 4 is equal to 1 and iota 8 is equal to 1. So this is also equal to each other. So students, we know that if iota power 4 is 1, iota power 8 is 1, then iota power 12 is also 1, because this is iota power 4, iota power 4, iota power 4. So this is 1 into 1 into 1 is equal to 1. So every multiple of 4 is equal to 1. Example, iota power 4, iota power 8, iota power 12, iota power 16, all the numbers are equal to 1. Okay students? So every multiple of 4 is equal to 1 and we have iota power 81, then we know that the multiple of iota power 4 is this. This is iota power 4, this is iota power 4, this is iota power 4, this is 448, 448 is 16. Similar, iota power 4, iota power 4, iota power 4, iota power 4, this is also this type. So we know that iota power 81 is equal to iota power 4 into 20 plus 1. So this is equal to iota power 80 plus 1. We know that iota power 80 into iota power 1, 80 is the multiple of 4. So the value of iota power 80 is equal to 1. Similar this condition. So this is equal to 1. This is iota. So we have answer iota. Okay. Okay students. Now we have many examples of exercise 5.1. The first example is find the value of iota power 27. So the value of iota raised to 27 is, we know that this is iota raised to 27. So this is multiple of 4 into 4 into 4 into 4 into 4 into 4. This is plus 3. This is 24 and this is 3. So total is 27. And we know that this is iota 4, 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 this is iota 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And this is iota power 3. And we know that iota power 4 is equal to 1. So this is 1 into 1 into 1 into 1 into 1 into 1 into iota power 3. When iota power 3 is multiplied by 1, then we find value iota cube. And iota cube is the iota into iota square. And we know that value of iota square is -1. So -1 is multiplied by iota, then we find minus iota, and value of iota is root -1. So the answer is minus root -1. So the answer of iota power 27 is equal to minus root -1. Now the next example is, find the value of iota power -8. This is also very important question. The value of iota power -8. So the solution is, this is iota power -8. Iota power -8 is equal to 1 upon iota power 8. And we know that iota power 8 is equal to iota power 4 into iota power 4. Iota power 4 is equal to 1. So this is 1 into 1. 1 into 1 is equal to 1. So the answer is equal to 1. So iota power -8 is always be equal to 1. Now the next example is, find the value of 1 upon iota. Find the value of 1 upon iota. So the solution is, we know that we have 1 upon iota. By the rationalize, we multiply iota in denominator and numerator. Okay, so this is iota by iota. We know that iota into 1 is iota, and iota square, this is iota, so it is iota square. Iota square is equal to -1. So iota upon minus iota is equal to minus iota. Okay student, so 1 upon iota is equal to minus iota. This is very important condition. 1 upon iota is equal to minus iota. Okay students, now the next example is, find the value of iota power 0. We know that every number who have power 0, then it is equal to 1. because x power 0 is equal to 1, y power 0 is equal to 1, and we know that 0 is also multiple of 4. 4 into 0 is equal to 0. So every number of multiple of 4 is always be equal to 1. Okay students? Now we find the value of 1 upon 1 minus iota in complex form. Okay students? Now we find value of 1 upon 1 minus iota in complex form. We know that we have z equal to 1 upon 1 minus iota. Now again rationalize. So the rationalization is 1 upon 1 minus iota is multiplied by, we change the sign of iota, so this is 1 plus iota and this is 1 plus iota. So 1 plus iota multiplied by 1 is equal to 1 plus iota, and we know that this is the formula of a plus b, a minus b, and we know that a plus b, a minus b is equal to a square minus b square. So this is a and this is b. So 1 square minus iota square. So this is 1 plus iota. 1 square is equal to 1 and iota square is equal to minus 1. So minus minus is equal to plus. 1 plus 1 is equal to 2. Now this is equal to 1 upon 2 plus 1 upon 2 iota. Okay, because we know that if a plus b upon 2, then we change it in the form a upon 2 plus b upon 2. So this is the in the form of x plus iota y. So x is real number and real number is equal to 1 upon 2, and similar y is equal to imaginary number. So imaginary number is equal to 1 upon 2. Okay students, this is very important question of exercise 5.1. So if z equal to x plus iota y and 1 upon z equal to x plus iota y, then we say that if z equal to 1 upon x plus iota y, then we rationalize this by x minus iota y upon x minus iota y. If we have z equal to 1 upon 2 minus 3 iota, then we multiply this by 2 plus 3 iota upon 2 plus 3 iota. If we have only z equal to 1 upon 2 iota, then we multiply this by 2 iota upon 2 iota. Okay students, thank you. Hello students, now in this class we have many questions of exercise 5.1. We know that exercise number 5.1 is the complex number, and complex number is the combined form of real and imaginary number. Now let me start with some examples. The first example is, so in the form of a plus iota b. Okay students, now the first part is 1 plus iota whole square. Okay students, now we change this in the form of a plus iota b. Now we know that a plus b whole square is equal to a square plus b square plus 2ab. Okay students, now this is 1 plus iota whole square. We know that a equal to 1 and b equal to iota. So the formula is changed in the form a square. This is 1 square. This is b square. This is iota square. This is 2ab plus 2 into a into b. Okay students, this is a plus b whole square, and a plus b whole square is a square plus b square plus 2ab. Now 1 square is equal to 1, iota square is equal to minus 1, and this is 2 iota, and we know that 1 is cancelled out by 1, so we find answer is 2 iota for 1 plus iota square. And this is very important result of exercise 5.1, that 1 plus iota whole square is equal to 2 iota. Okay students, now the second question is 1 minus iota whole square. Now we know that a minus b whole square is a square minus 2ab plus b square. Okay, we know that a is equal to 1 and b is equal to iota. So the formula of a minus b square is a square minus 2ab plus b square. So the change form is 1 square minus 2 into 1 into iota plus iota square. So we know that 1 square is equal to 1. This is 2 iota, and iota square is equal to minus 1. So 1 is cancelled out by 1, then we find minus 2 iota. This is also very important result of exercise 5.1, that 1 minus iota whole square is equal to minus 2 iota. Okay students, now the third question is 1 minus iota power 4. Okay students, this is very important question, but we know that this is 1 minus iota whole square and 1 minus iota whole square. Okay students, and we know that this is in the form of 1 minus iota square, and 1 minus iota square is equal to minus 2 iota by the previous result. So this is minus 2 iota whole square. The value of 1 minus iota whole square is minus 2 iota, and this is also minus 2 iota. Minus minus is equal to plus. 2 2s are 4, and iota into iota is iota square, and we know that iota square is equal to minus 1. So the answer is 4 into minus 1 equal to minus 4. 4. The question number 4 is 1 plus iota power 4. We know that this is the multiple of 1 plus iota square and 1 plus iota square. By the previous result, we know that the answer of 1 plus iota square is 2 iota. So this is 2 iota into 2 iota. This is 2 to the 4, and we know that iota square is -1. So our answer is -4. Okay students, this is very important question of exercise 5.1. Now the fourth question is solved in the form of a plus iota b, where z equal to 5 iota into minus 3 upon 5 iota. We know that this is 5 iota and this is minus 3 upon 5 iota. 5 is cancelled by 5, so this is minus 3. Iota into iota is iota square, and we know that iota square is -1, so our answer is 3. Okay students, now the next question is question number 5. The fifth number is find in the form of a plus iota b. The question is 1 minus iota minus 1 plus 6 iota. So when we solve this, this is 1 minus iota minus plus 1 plus minus 6 iota. We know that 1 plus 1 is equal to 2 and minus 6 iota and minus iota is minus 7 iota. So this is in the form of a plus iota b, where a equal to 2 and b equal to minus 7. Okay students, now the sixth question is solve in the form of a plus iota b. The question is 1 upon 3 plus 3 iota whole cube. Okay students, now we know that this is a plus b whole cube, and the formula of a plus b whole cube is a cube plus b cube plus 3 a square b plus 3ab square, where a equal to 1 upon 3 and b equal to 3 iota. When we put the value of a and b, so this is 1 upon 3 whole cube, this is b is 3 iota whole cube plus 3 a square, this is 1 upon 3 whole square, this is b is 3 iota. Now this is 3, this is a is 1 upon 3, and in the last this is b square and b is 3 iota square. Okay students, this is the form of a plus b whole cube, where a cube plus b cube plus 3a square b plus 3ab square. Now this is 1 upon 27, this is 27 iota cube, this is 3 into 1 upon 9 into 3 iota, and the last is 3 into 1 upon 3 into 3 iota whole square, and we know that what is the 3 iota whole square? This is 9 into iota square. Now we solve this. This is 1 upon 27, this is 27 iota cube. Now this is 3 into 3 is cancelled out by 9, so we find iota, and in the last 3 cancelled out by 3, so we find 9 iota square, and we know that iota cube equal to minus iota and iota square equal to minus 1. Okay, this is the important value. Iota cube equal to minus iota and iota square equal to minus 1. Now the last question of exercise 5.1 is solve in the form of a plus iota b, where z equal to minus 2 minus 1 upon 3 iota whole cube, and we know that minus sign is common, then this is 2 plus 1 upon 3 iota whole cube. Okay students, now we know that this is the formula of a plus b whole cube. This is the formula of a plus b whole cube, and we know that what is the expression of a plus b whole cube is a cube plus b cube plus 3 a square b plus 3ab square. Okay students, where a is 2 and b is 1 upon 3 iota, where a is 2 and b is 1 upon 3 iota. Now we solve this. A cube, this is a cube. Okay, now b cube, this is b cube. Now 3a square b, so this is 3, this is a square, and in the last this is b, and plus 3a b square. So the formula is changed in the form of a plus b whole cube is a cube plus b cube plus 3a square b plus 3ab square. Now we can solve this. 2 power 3 is equal to a. This is iota cube. 3 power 3 is 27. Now this is 3. 2 power 2 is equal to 4, and the last is 1 upon 3 iota. Now this is 3, this is 2, and square of 3 is equal to 9, and this is iota square. Okay students, so 2 power 3 is equal to 8, 3 power 3 is equal to 27, this is iota cube, this is 3, 2 square is equal to 4, this is 1 upon 3 iota, and the last this is 3, this is 2, this is square of 3 is equal to 9, and this is iota square. But we know that iota square is equal to minus 1 and iota cube is equal to minus iota. So the value is changed, and we know that iota cube is equal to minus iota, so this is minus iota upon 27. This is cancelled out by 3, so we find 4 iota, and in the last 3 is cancelled out by 3, and iota square is equal to minus 1, so we have minus 2 upon 3. Okay students, now separate to each other. This is minus, this is 8, the values are real, so connect to each other, and the values are imaginary, so this is 4 iota minus iota upon 27. Okay students, now the next value is for the real and imaginary number. We can solve this by some solution of method. Just like we know that the LCM of these two number is 3. So this is minus 8 upon 1 minus 2 upon 3 plus 4 iota minus iota upon 27. Okay students, now the LCM of 1 and 3 is equal to 3. This is 8. 8 3s are 24 and this is 2. Now the LCM of 1 and 27 is 27. 27 is multiplied by 4. We know that 27 is multiplied by 4. Then we find 108. This is 108 iota minus iota. Okay students, now 24 minus 2 is equal to minus plus is equal to minus, but bigger number is 24, then the sign is positive. So we find 22 upon 3. 108 minus 1 is equal to minus plus minus, but bigger number is positive. So this is 107 iota upon 27. Okay sir, now change the sign. This is plus minus minus 22 upon 3 and plus minus minus 107 upon 27 iota. Okay students, this is very important question of exercise 5.1. So it is in the form of a plus iota b, where a is real part is minus 22 upon 3 and b is imaginary part, and imaginary part is equal to minus 107 upon 27. This is very important question of exercise 5.1. Now the next question of exercise 5.1 is solve in the form of a plus iota b. So question number 6 is solve in the form of a plus iota b. The question is 1 upon 1 plus iota whole square. Okay students, now let us start with solution. The solution is, this is in the form of a plus b whole square. And we know that what is the expression of a plus b whole square? A plus b whole square is equal to a square plus b square plus 2ab. We know that this is a square plus b square plus 2ab, where a is equal to 1 and b is equal to iota. So this is a square, a is 1. This is b square, b is iota. This is 2ab, so 2ab is 2 into 1 into iota. Okay students, now 1 square is equal to 1, iota square is equal to minus 1, and in the last this is 2 into 1 into iota is equal to 2 iota. So we know that 1 is cancelled out by 1, so we find only one digit. This is 1 upon 2 iota, but this is not in the form of a plus iota b, so we use rationalization. So rationalize 2 iota, okay, by numerator and denominator. So we know that 2 iota is multiplied by 1, then we find number. This is 2 iota, and we know that 2 2s are 4, and this is iota multiplied by iota, so this is iota square. And we know that what is the iota square? Iota square is equal to minus 1. So this is 2 iota upon minus 1 into 4 is equal to minus 4. 2 is cancelled out by 4 is 2 times. So our answer is minus 1 upon 2 iota. We don't have real part in this question. So we use 0 plus minus 1 upon 2 iota. So it is in the form of a plus iota b. So a equal to 0 but b equal to minus 1 upon 2. Okay students, this is also a very important question of exercise 5.1. Hello students, today I am going to teach you another very important topic of complex number. The name of chapter is complex number and the topic is complex number in polar form. Okay students, this is very important topic of complex number. We change complex number in the polar form. Okay, let we have a graph. The graph is, this is the graph. This is 1 point. The coordinate of P is xy. This is a point on the graph. The distance from the x-axis is y and distance from the y-axis is x. So this is the x-axis, this is the y-axis and this is the origin of this graph. And pxy is the given point. So the distance OP. The distance OP is r. Then we change it in the polar form. In the polar form, x and y coordinates are x equal to r cos theta and y equal to r sin theta, because we know that this is r, this is y and this is x-axis. So in the triangle OMP and ONP, in triangle OMP we know that hypotenuse is r and perpendicular is y. So we know that the formula is sin theta equal to P upon H. P is y and H is r. So P upon H is equal to y upon r. So sin theta equal to y upon r, and by the cross multiply, y into 1 is equal to y equal to r sin theta. Similar, by the graph OLP, x equal to r cos theta. Similar, in graph OPN, the triangle name is OPN. We know that if y equal to r sin theta, then x equal to r cos theta. This is the first equation and this is the second equation. So by two equations we find argument and conjugate. So by equation number 1 and equation number 2, by equation number 1 and equation number 2, x square plus y square, this is x square plus y square, x square is equal to r square cos square theta, r square cos square theta, and y square equal to r square sin square theta. And we know that what is the common number between two terms? This is r square. So this is cos square theta plus sin square theta, and we know that what is the value of sin square theta plus cos square theta? It is 1. So this is r square into 1. So the answer is r square. This is x square plus y square. So the argument and conjugate from the distance is r equal to under root x square plus y square. This is the modulus of r, and modulus of r is equal to under root x square plus y square. Okay students, this is the value of r square is equal to x square plus y square. Now again, by the equation number 1 and equation number 2, we divide equation number 2 by equation number 1. We know that what is the equation number 2? This is y equal to r sin theta, and equation number 1 is x equal to r cos theta. So r sin theta upon r cos theta equal to y upon x. This is r sin theta, this is r cos theta, this is y, and this is x. So r is cancelled out by r, and we know that sin theta upon cos theta is equal to tan theta, and this is y upon x, and theta equal to tan inverse y upon x. This is the argument of complex number. This is the argument. Okay students, so we find in the complex number, if z equal to x plus iota y is the complex number, then its z inverse is equal to 1 upon z. This is called multiplicative inverse. And we know that its value of iota is equal to under root minus 1, iota square equal to minus 1, iota cube equal to minus root minus 1, iota power 4 is equal to 1, and we know that last two formulas are modulus is equal to z equal to under root x square plus y square, and in the last the argument is theta equal to tan inverse y upon x. So students, this is very important results of complex number. This is first this is second, third, fourth, fifth, sixth, seventh and last n. Okay, thank you students. In next class we solve many examples and many formulas of complex number. Now students, we have many examples of exercise 5.2. In exercise 5.2, we find the polar form of complex number. We know that what is the complex form? The complex form is x equal to r cos theta and y equal to r sin theta, then z equal to r bracket cos theta plus iota sin theta. So, change complex number in polar form. We know that if z equal to x plus iota y is the complex number where x equal to r cos theta and y equal to r sin theta, then z equal to r cos theta plus iota r sin theta is called polar form. The next equation is r, then we find cos theta plus iota sin theta is called an important, very important form of complex number. The form is called polar form. So, let me have an example of exercise 5.2. The example number 1 is find the polar form of complex number, and the complex number is root 3 plus iota. The complex number is root 3 plus iota. This is the complex term. So, we find its polar form. Okay students, now let me start with the procedure. The procedure is let x equal to r cos theta and y equal to r sin theta by these formulas. So, in the starting, we know that z equal to x plus iota y, where x is r cos theta and y is r sin theta, and the complex number is z equal to, the given number is z equal to root 3 plus iota. So root 3 plus iota is changed in the form root 3 plus iota and bracket is 1. So, by comparing, we find x equal to root 3 and y equal to 1. X equal to root 3 and y equal to 1. And we know that x equal to root 3. So, x equal to r cos theta, and this is root 3, and the second equation is y equal to r sin theta, and this is 1. Okay students, by the compare of two equations, x plus iota y, root 3 plus iota 1. So, this is the equation number 1 and this is the equation number 2. By same procedure, by equation 1 and 2, we have the square of both sides. This is r square cos square theta, this is r square sin square theta. Then we know that what is the formula? The formula is z equal to under root x square plus y square. This is the modulus of equation. This is also equal to r. R is the distance from origin to point. Then the value of x is root 3 and value of y is 1. Then the square of root 3 is 3 and the square of 1 is 1. Then root 3 plus 1 is 4 and this is 2. This is always be positive because the distance is always be positive. Now again by equation 1 and 2 we know that what is the formula of argument? The theta equal to tan inverse y upon x. So y is 1 and x is root 3. So theta equal to tan inverse 1 upon root 3. Okay students, theta equal to tan inverse 1 upon root 3 and this is the angle of how many angles? This is theta and 1 upon root 3 the value is in 10 ratio. So we find the value is theta equal to 30 and 60. Give me the answer. Okay students? The answer is pi by 6 and pi by 6 is equal to 30 degree. Okay students? This is the value of theta and this is the value of r. And the polar form is x equal to, the polar form is x equal to r cos theta plus iota sin theta and put the value of r and theta. The r is 2 and the theta is pi by 6. Okay students, this is the correct answer of this question. The question is change the complex number in the polar form where z equal to root 3 plus iota. Now the second example is change into polar form and we have z equal to iota. This is not in the form of x plus iota y. Then this is not in the form of x plus iota y. Then we change this in 0 plus iota 1. Okay students? And we know that x is equal to 0 and y is equal to 1 where x is equal to 0 and y equal to 1, then we know that r equal to under root x square plus y square. The value of x is equal to 0 and value of y is equal to 1. So the answer is always be 1 of this complex number. This is the value of r. R is the modulus. Now theta equal to tan inverse y upon x and value of y is 1 and value of x is 0. And we know that 1 upon 0 is equal to infinite. And what is the value of theta in 10 quadrant? Then we find infinite, it is pi by 2. So the complex number, the complex form in the polar form is z equal to r cos theta plus iota sin theta. Put the value of r and theta. The r is 1 and the theta is cos pi by 2 plus iota sin pi by 2. This is the polar form of complex number. If the complex number is x, z equal to x plus iota y, then its polar form is z equal to r bracket cos theta plus iota sin theta. Okay students, thank you. Hello students, now the next question of exercise 5 chapter name complex number. Convert in the polar form. The question is z equal to 1 plus 7 iota upon 2 minus iota whole square. Change it in the polar form, and you know that what is the polar form? Polar form is in the form of z equal to x plus iota y, where x is the real part and y is the imaginary part. Now we know that this is 1 plus 7 iota and this is whole square of 2 minus iota. And you know that what is the a minus b whole square? A minus b whole square is equal to a square minus 2ab plus b square. So changing in the form a square plus b square minus 2ab. Okay students, a square plus b square minus 2ab. If it is in the form of 2 plus iota square, then this is a square plus b square plus 2ab. Now 1 plus 7 iota, 2 square is equal to 4, iota square is equal to minus 1, and 2 2s are 4 and 4 multiplied by iota, then we find minus 4 iota. Okay students, now 4 minus 1 is equal to 3. Okay students, now this is numerator and this is denominator. Now rationalize. 1 plus 7 iota upon 3 minus 4 iota. It is multiplied by 3 plus 4 iota upon 3 plus 4 iota. We can change the sign. This is minus and minus change in the plus form. So 1 plus 7 iota is multiplied by 3 plus 4 iota, and it is in the form of a plus b, a minus b, and you know that very well that a plus b, a minus b is a square minus b square. Now multiply to each other. 1 3s are 3, 1 into 4 iota is 4 iota, 7 iota into 3 is 21 iota, and 7 4s are 28, and this is iota square. Iota multiplied by iota, then we find iota square. We know that 3 square is equal to 9, 4 square is equal to 16, and this is iota square, and iota square is equal to minus 1. Now this is 3 plus 4 iota plus 2 iota. Iota square is equal to minus 1. So this is minus 28 upon 9 minus minus is equal to plus, then plus 16. We know that 28 and 3, when we solve this, we find minus 25. We find minus 25, and 4 iota plus 2 iota is equal to 6 iota. Now it is divided by 25. Now minus 25 is divided by 25 plus 6 upon 25 iota. This is minus 1 plus. So we know that 3 minus 28 is equal to minus 25, and 21 plus 4 is 25 iota minus 25 upon 25 plus 25 upon 25 iota. 25 is cancelled out by 25 and now 25 is cancelled out by 25. Then we find minus 1 plus iota. It is in the form of complex. This is z equal to minus 1 plus iota. Now we can change it in the polar form. And you know that what is the polar form? Polar form is z equal to r bracket cos theta plus iota sin theta. So this is z equal to minus 1 plus iota. We know that z equal to x plus iota y. Now compare x is equal to minus 1 and y is equal to 1. The coefficient of iota is equal to 1. We know that x equal to r cos theta and y equal to r sin theta. The value of x is equal to minus 1 and value of y is equal to 1. This is first equation and this is second equation. Now by 1 and 2 square on both sides, then we know that the formula of modulus is r equal to under root x square plus y square. The value of x is equal to minus 1 and value of y is equal to 1. So minus 1 square plus 1 square is equal to 1 plus 1. Then it is equal to root 2. Then we find r equal to root 2. Now we find theta of complex number when we have x equal to minus 1 and y equal to 1. So x equal to r cos theta and value of x is equal to minus 1 and y equal to r cos theta and value of y is equal to 1. And we know that the value of x is equal to minus 1 and value of y is equal to 1. It is in the second quadrant. Theta is in the second quadrant because in the second quadrant the value of xy is minus 1 and 1. This is the second quadrant. This is first, this is third and this is fourth. Here all positive, here negative and positive, here negative and negative, and in the last this is value of x is positive and value of y is negative. So this is in the second quadrant. For the second quadrant we cancel out by pi. So we know that theta equal to tan inverse y upon x. So tan inverse value of y is equal to 1 and value of x is equal to minus 1. When we solve this, we find tan inverse minus 1 and tan inverse minus 1 is in the second quadrant. This is the second quadrant, and in the second quadrant the value is equal to 3 pi by 4 because this is 90 and this is pi by 4. So when we solve this, we find answer is 3 pi by 4. Second type is theta equal to pi minus pi by 4 is always be equal to 4 pi minus pi is equal to 3 pi by 4. So theta is equal to 3 pi by 4 and r equal to root 2, and we know that what is the complex form? The polar form is r cos theta plus iota sin theta. The value of r is root 2 and value of theta is 3 pi by 4. So this is the answer of question of exercise chapter number 5. Thank you. Okay students, now we use another formulas and another questions of exercise 5. The chapter name is complex number, and we know that what is the definition of complex number? The combined form of real and imaginary number is called complex form, complex number. Complex form is in the form of a plus iota b, where a is the real part and b is the imaginary part. Now we have many questions. So first question is z equal to iota raised to 18 plus 1 upon iota raised to 25 whole bracket power 3. Now we can solve this in the form of a plus iota b. Now let us start. The solution is, first we have iota power 18. Iota raised to 18 is equal to iota raised to 4 into 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 iota raised to 2. We know that 4 4 8, 4 4 8, 8 8 16 and 2 18, and we know that iota power 4 is 1, 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 and iota square is equal to minus 1. When we multiply this, we find answer minus 1. Now, second, we know that the power of iota is 25. Then this is iota power 4, 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 iota power 4. 1, 2, 3, 4, 5, 6. 6 4 is 24 and plus 1 remaining. Okay, now we know that this is 1, 1, 1, 1, 1, 1. And in the last, this is iota. So, iota is multiplied by 1, then we find iota. So, the power of iota is 18, then we find answer minus 1, and iota raised to 25 is the answer is iota. Now, put the values in this equation. This is iota power 18, so this is equal to minus 1. And now plus this is 1 power of 25 is equal to 1, and iota raised to 25 is equal to iota. The power is 3. We know that in previous questions, what is the value of 1 upon iota? The value of 1 upon iota is equal to minus iota. So this is in the form of minus 1 minus iota power 3. Okay, now the common is minus. So we find 1 plus iota whole cube. This is the formula of a plus b whole cube. Then we know that a plus b whole cube is a cube plus b cube plus 3 a square b plus 3 ab square. Now we put the value a equal to 1 and b equal to iota. So this is 1 cube plus iota cube plus 3 into 1 square into iota plus 3 1 into iota square. So we know that 1 cube is equal to 1. Now iota cube is equal to minus iota. Now this is 1 square is equal to 1 3 is multiplied by iota, then we find 3 iota. And in the last, this is iota square. Iota square is equal to -1. So this is -3. Now we know that -3 plus 1 is equal to -2. And 3 iota minus iota is equal to plus 2 iota. Now we can change the sign. This is minus minus plus, and this is minus plus minus. So it is in the form of a plus iota b, where a is real part and real part is equal to 2, and b is imaginary part and imaginary part is equal to -2. Okay students, so it is in the complex form a plus iota b. Now students, the next question is, if x minus iota y is equal to under root a minus iota b upon c minus iota d, then prove that x square plus y square is equal to a square plus b square upon c square plus d square. This is the first equation. Equation number 1 is x minus iota y is equal to under root a minus iota b upon c minus iota d. Now we can change the rule of iota. The iota rule is, if x plus iota y is, then we can change the sign of iota. This is under root a plus iota b upon c plus iota d. This is the second equation. Now we multiply equation number 1 with equation number 2. Okay students, now the equation number 1 is x minus